In this video, I am going to show you how to use your calculator and use something called rref, which stands for Reduced Row Echelon Form, to deal with initial conditions. If I have this system right here, then it gives me this this matrix A right here. And I hope you would be able to solve this at this point. I would, or you would, find the characteristic equation by doing the negative trace, that's the 8, do the det, gives me minus 9, factor, set it equal to 0, get lambda equal to negative 9, and lambda equal to 1, subtract along the diagonals, do my a minus lambda I for these guys and this guy, and then choose a vector that zeros it, get this. So if it's just a problem without initial conditions, then I am good to go. I am done. But say for this one, they told me x of 0 was equal to 4, and y of 0 was equal to negative 7. Okay? Then I need to solve for the c values that will work to give me that. So we need to plug in x equals 0 to this thing. Doing that is actually quite easy in the form that it currently is in. I can go x of 0 is c1 times 2 negative 3, and then it's e to the negative 9t, but t is 0. So what's that give me? Gives me e to the 0, which is 1. So I get x of 0 is c1 times this vector plus c2. The same thing's going to happen here. c2 times 1, 1. And what does that give me? That, if I write it in equation form, is the same as x of 0, y of 0, assuming that x vector is equal to xy, is equal to 2c1 plus c2 and negative 3c1 plus c2. And notice I can now solve for these c's because I know that 4 is going to go in right here and negative 7 is going to go in right here. So this becomes a system. 4 equals 2c1 plus c2, and negative 7 equals negative 3c1 plus c2. This becomes a system such that if I solve it, I get my c values. And sometimes when you're doing these differential equations, things like when you get to this point, it's a lot of work to continue to do this. And in my class, I'm totally fine if you use a calculator to do this work for you. You can use substitution or elimination or something like that if you want. In this case, I could subtract this line from that line, right? But I want to use this as a demonstration to show you how we can use reduced row echelon form on the calculator. Because especially when we get to things that have more than just two variables, we don't want to be doing this. So I'm actually going to switch the order in which this is written. I'm going to write it as 2c1 plus c2 is equal to 4, and then negative 3c1 plus c2 is equal to negative 7. What I'm going to do is write this in a matrix, write this using a matrix. I'm just going to rip the coefficients. This can be represented with a matrix by writing 2, 1, a bar. The bar doesn't mean anything. You can just think of it as the equal sign. 4, and then negative 3, 1, negative 7. Ugh. So what I can do is put this in my calculator and type rref, and it'll give me the solution out. Okay, so we will go to, we'll get the second button. We will hit X inverse, which takes us into the matrix menu. I'm going to go over to Edit. I'm going to create a 2 by 3 matrix. It's going to be 2 tall and 3 wide. And now I'm going to type in those numbers from my matrix over on the other sheet. That was 2, 1, 4, and like I said, the bar is just there, so it sort of represents the equal sign. Doesn't matter in the matrix here. And then negative 3, 1, negative 7. Okay, I double check it. 2, 1, 4, negative 3, 1, 7. I can quit, and then I can go back into the matrix menu, and I go over to this math menu here, math, and it's down pretty far. I think it's easier to get to it if we go up around the back, and you can see this rref right here, bam, and now I can take the matrix A and hit enter, and boom, I get 1, 0, 2.2, and then 0, 1, negative 0.4. Before I go back to the other page and show you what this means, I want to show you something else that's cool about our calculators. I can math frac a matrix. So I can pull up math, or I can frac it, answer frac, and whabam, it gives me 11/5 and 2/5. And if you prefer to use decimals, which I sometimes, or if you prefer to use fractions, which in this case I sometimes do, then we can go and we can use this instead of the decimal version. So let's copy this onto our paper over there. So you can see here that I rref'd this thing to get 11/5 and 2/5. So if I were to do the opposite of what I did to get this thing into a matrix and take this matrix and turn it back into the system, then what this would be representative of is 1 times C1 plus 0 times C2 equals 11/5, and 0 times C1 plus 1 times C2 equals negative 2/5. So another thing that this says, if I just multiply and look at it, right, this really just says C1 equals 11/5 and C2 equals negative 2/5. What I want to point out here is that you can go through this process very, very quickly. I showed all these steps, but I think that you could do it without much work, and it helps you deal with initial conditions when you have a system like this. Because what's that tell me? 11/5, 3/5, negative 2/5. I can take this right here, and my particular solution that would have these initial conditions, initial x and initial y of these guys, is going to be x, not of 0, of t is equal to, all right, C1, I just write 11/5. Then I open my vector, 2, negative 3, e to the negative 9t, plus, minus, in this case, 2/5 times 1 e to the t. Okay, let's do one more example here. Say I had this system. You would be able to get the A. You would be able to do the characteristic equation using a negative trace and a determinant. Factor it to 0, get 3, negative 1, get these guys, get that factor and that factor to have this be the solution. But what if I asked you to do it with initial conditions of 4, negative 3 for x of 0? Notice that's an x vector of 0. Well, what I can do is write, I'm going to kind of flip this. I'm going to plug in 0, which gives me C1, that's this times that, times e to the 0, plus C2, and then times 1 times that, e to the 0, equals my 4. That's this one. And then when I plug in 0 for this one, I get C1 minus C2 equals negative 3. Now again, I know that this one we can solve actually pretty easily with elimination. You might be able to do it in your head, but let's practice doing this with the calculator. 1, 1, bar, 4, 1, negative 1, bar, negative 3. I want you to go ahead and put that into your calculator using in the matrix menu. Again, do this along with me. I'm going to go second matrix over to matrix A. Notice it's got the stuff in there from before, so I'm just going to go through there till I get to here. I'm going to go 1, 1, 4, and then 1, negative 1, negative 3, enter. And now I'm going to quit out of here. I'm going to go second matrix, oops, go over to math, go back around the top, find rref, and then go second matrix, select matrix A, hit enter, boom, I get a half and 3.5. And if you can't see that, you can go ahead and go, or in 7/2, I should say. We can math bracket a half and 7/2. So I am okay in this class with you drawing an arrow, writing rref, and saying C1 is 1/2 and C2 is 7/2. And then what you can do is write out the solution. For bam, I get x equals 1/2 times 1 e to the 3t plus 7/2 times 1 e to the negative t. What this does for me, really, in this class, is it lets us focus on the calculus side of things and not worry about solving all these systems. You should still be okay with solving systems, especially two-variable systems by hand. But for now, for the purposes of what we're doing in this course, you can use these tricks with your calculator. I will link for you in the description a video that goes into a little bit more depth about what rref is and why it's important and how it is associated with a system of equations and why that that 1001 here is representative of this. But for now, you can use this, and I hope it helps.